talking about deep learning using TensorFlow. So when I was getting into TensorFlow, I thought it was just a Python module. However, it's not a Python module. It's not only a Python module. It's created by Google. You can use it on C++, Java, and Python. So what does TensorFlow do? It basically creates neural networks for your method or your program to learn from user input. Okay, so in our program, what do we do? So I try and think of something that will help our society, right? So my model, what it does is it takes in an array of 3,000 vegetables, and it tries and memorizes or learns the shapes and types of vegetable it is. And when the user uploads any new vegetable to it, it predicts what type of vegetable it will be, and with the accuracy percentage of how much accurate your model is on while predicting the vegetable. So you might be asking, like, how is this helpful to society? It can be helpful to society if you're uploading images of MRI scans of brain tumors. So companies like Flatiron Health, they use the same exact module, TensorFlow, to identify brain tumors and the types of brain tumors there are. This is my design algorithm. So it first takes in a picture, and it condenses it and makes it smaller, so it's easier for the model to process. So it turns it into a 0 to 1 pixel, and then when you train, so first you have to train the model, and then validate that particular data, and then you have to so it's train, validation, and test. So in training part, you can use NumPy or Keras library within TensorFlow in order for you to break down that image. So it goes from 3D images to 1D, to 2D to 1D. Also, during training, you have to decrement your neurons by 20%, because if you have all of your neurons, your model will end up memorizing that particular picture. It's not going to actually learn from it. So that's why you want to drop 20% of neurons while training. This is my SDLE implementation. We're going to skip this and go right into the code. So this is the code for it, similar to Kobe's. I use Jupyter Labs notebooks. I'm just going to go 3 blocks. So here you're importing all the modules, and this is your training path, right? So we have three variables: train, test, and validation. So on first block, on block 7, you train your model. So the way you train your model, you set the path to wherever you're storing the images of the vegetables, right? So as you can see, there's an array of folders, and within these folders, there's pictures of vegetables that you can upload to your model. So when you're training it, you're uploading that picture, and you're telling your program that it is an apple. So you're telling it that it's an apple. When you're validating that data, you upload new pictures, but you do not tell it what type of data it is. Okay. So there is another picture or another folder for validation, and then for testing, you don't tell it what type of vegetable it is or image it is, and you upload new pictures to it, so it validates itself. We're going to go to our accuracy and loss rating. So this is plotted by Mathplot library. So you can use this library to plot out your accuracy and training loss during training. So as you can see, my model, my particular model, it's highly accurate with a low percentage of loss. Also, lastly, this is the last part that I want to show you guys. I created a user interface using Streamlit library within Python, where a user can actually upload any new picture or any pictures of those vegetables that the model have not taken before. So if you do deploy this, you get like a web server, something like this, and within this you can upload any new image. So we're just going to test it with one image. Unfortunately, you cannot drag and drop. You do have to name the file that you want to upload. So let's say we want to do like a banana image, right? So that is this image. This image has not been uploaded here before, so we're just going to upload it real quick. And once you do hit enter, yeah, it should say this fruit is a banana, and the accuracy rating is 91% that it is a banana. So yeah, you can use the same model for brain tumors or anything in real life scenarios. That's my project.